Infinity is a perplexing idea which basically refers to something that grows without bound. No matter what number you might assign to something, infinity will be larger than that number. We make use of infinity in a number of ways in physics. We imagine that space conceivably could go on infinitely far. We imagine that in principle the universe could go on for an infinite amount of time. But in our calculations, if infinity turns up as the answer to something that we could directly measure with a piece of equipment, then we know that our calculation must be wrong. And we have used that as a diagnostic over many decades to tell us if you find infinity popping out of your equations for something you can measure, you better go back. Think about those equations, modify them in some way in order to get a finite answer, as that's the only kind of answer that we could ever directly measure.
This simulation shows what you might see if you were orbiting a black hole. The light and position of background stars around the hole are distorted by its gravity, and they seem to spin around. On the right, the constellation Orion appears to approach the event horizon, the boundary from which nothing can escape. Orion's stars look like they become separated and get spun around. Once the hole has passed by, Orion reappears on the left and looks normal again. Users can also experiment with different scenarios. This is what you might see if you were traveling towards a black hole, with rocket engines slowing your descent. Another simulation mimics freefall into a hole. In the middle, the light of the entire universe appears to be concentrated in a bright ring.
Welcome to the Four Winds Historical Farm, where traditions of the past are preserved for visitors like you. Today, our master thatchers will begin giving this barn behind me a sturdy thatched roof, able to withstand heavy winds and last up to 100 years. How do they do it? Well, in a nutshell, Thatching involves covering the beams or rafters, the wooden skeleton of a roof, with reeds or straw. Our thatchers here have harvested their own natural materials for the job, the bundles of water reeds you see lying over there beside the barn. Thatching is certainly uncommon in the United States today. I guess that's why so many of you have come to see this demonstration. But it wasn't always that way. In the 17th century, the colonists here thatched their roofs with reeds and straw, just as they had done in England. After a while, though, they began to replace the thatch with wooden shingles because wood was so plentiful, and eventually other roofing materials like stone, slate, and clay tiles came into use. It's a real shame that most people today don't realize how strong and long-lasting a thatched roof is. In Ireland, where thatching is still practiced, the roofs can survive winds of up to 110 miles per hour. That's because straw and reeds are so flexible. They bend but don't break in the wind like other materials can. Another advantage is that the roofs keep the house cool in the summer and warm in the winter. And then, of course, there's the roof's longevity. The average is 60 years, but they can last up to 100. With all these reasons to start thatching roofs again, wouldn't it be wonderful to see this disappearing craft return to popularity?
I think one of the things that's confusing for people is when they come here is there appear to be hundreds and hundreds of rules, hundreds of things you should and shouldn't do. And the truth of it is most of them are about class. And lots of them are tripwires, actually, for people who don't know them. So what I tried to do in my book was take it back to some sort of first principle and say, look, there are anthropological reasons why we have certain kinds of manners. So I'll give you a very good example. In Britain, there are sort of two ways of holding a knife very broadly. And broadly speaking, the middle classes hold it with the index finger on the top, gripped in the hand, and working class people hold it like a pen. Entirely a class distinction, and people mercilessly exploit it if they want to. The truth of it is, the one way not to hold a knife at the table is clasped in your fist, raised, as if to kill your guest. And what does that tell us about eating? Well, what it tells us about eating is two things. It's never confuse your guests with either the food or the enemy. Don't eat them and don't kill them. That's about how you should hold your knife, because actually manners are really about the reduction of violence. There's a lot in there about reducing violence. So that's just an illustration of what one tries to do. So actually, when you look at real table manners, they're about people feeling comfortable with each other, sharing food around a table. Very important human thing.
And I think The American people are fed up with partisan politics. In a recent Gallup poll, Americans named dissatisfaction with government as the #1 problem facing the country today. Americans now believe our government is more of a problem than the economy, education, and terrorism. To change the way our elected officials work for the American people, we must change how they are elected. We need to start with the first round of voting, the primaries. Thanks to gerrymandering and other factors, the primary election is often the only election that matters. In many states, less than 5% of the electorate are actually deciding who represents 100% of that district or state. That means our elected officials are actually chosen by an increasingly tiny, often incredibly partisan slice of the electorate. Today, 42% of Americans identify themselves as independents. Most states exclude independent voters from voting in the first round, the primaries. And in states that do allow them to vote in primaries, they are forced to temporarily join a party that they don't believe in. A top 2 nonpartisan primary eliminates party control in favor of a single nonpartisan primary open to all voters and all candidates. There is no longer a Democratic primary and a Republican primary. There is one primary open to all voters and all candidates. The top 2 vote-getters, regardless of party, then move forward to the general election. With nonpartisan primaries, everyone gets to vote. The winners are more accountable because they have to speak to all the voters in order to get elected. Elections are more competitive. Legislators are encouraged to work across party lines and focus on issues we care about. Top 2 nonpartisan primaries are now used in California, Nebraska, and Washington. You've probably already voted using Top 2. Most municipal elections nationwide use this simple, nonpartisan system. Today, activists in all 50 states are working to bring this crucial system change to their state. The movement is growing. Join us and help us create a government that truly is by and for the people.
If we're thinking about this and we're trying to say, all right, well, let's file a patent on this clicker. If I were to go to the patent office and say, all right, I want a patent on a clicker, period. The patent office would just laugh. You know, the clickers have been around for a while, presentation clickers have been around for a while, and so there'd be a 0% chance that we would actually get that. If we were to somehow convince the patent office that we should be able to get a patent on a clicker, period, it would, however, be incredibly valuable. Every single clicker that was made after this point would infringe. And when it infringes, maybe we take $1 or $2 each. That would add up to be a decent amount of money. On the other end of the spectrum, let's go to the million-word version. I go to the patent office and I say, I want a patent on this exact thing. And those million words describe every single radius, every single material, every single thing about this. And the patent office says, yeah, we've never seen that before. Go ahead and take it. Almost 100% chance of getting that patent. But the value of that patent would be close to 0.
Can we never get to absolute zero? What a wonderful question. I wish I had a wonderful answer to go with it. Here's the problem. There is actually a law of physics called the third law of thermodynamics that says you cannot get to the absolutely zero. We don't really know it's true, but we are pretty sure it is for the following reason. Every time you think of some way of cooling something down a little bit, it means you try to get energy out of that thing and make the temperature lower. Well, if you can get energy out, usually there is a way that the energy can go in as well. And that always means there is a competition between taking the energy out and putting the energy in. Now, you can try to make it so you are favoring getting energy out, but you can't completely stop the energy from going in, and that means you might be able to get colder and colder, but you won't be able to get all the way to absolute zero. Could we go back to my PowerPoint? Because I think that one of these slides will illustrate that point a little bit better. Yes, here, remember the logarithmic thermometer? There is no zero on this logarithmic thermometer. It just keeps going down. You make it a fact of 10 colder, you're not a zero. You make it a fact of 10 colder, you're still not a zero. You make it a fact of 10 colder, you're still not a zero. So you start 1,000,000 of a degree. Now you are 10 millions of a degree. Now you are 100 millions of a degree. Now you are billions of a degree. You never get to zero that way. You get closer and closer, but you never get to zero. So that's why we cannot get to absolute zero.